We have understood the basics of total productive maintenance, and we also have understood that it is important to recognize the point that breakdown maintenance is not the goal of TPM. It is how to prevent such kind of unscheduled breakdown is the goal of TPM. However, when you experience a breakdown, it is very important for us to understand how to reach the root cause for the occurrence of that particular breakdown. Having said that, it is important to identify the required tool for analysis of such kind of breakdowns. And YY analysis is one such great tool for doing such kind of analysis. Before I go into the details of YY analysis with an example, I would like to explain the difference between the other type of cause and effect diagram and YY analysis. In fact, YY analysis is also one type of cause and effect analysis. The only difference is that here, in case of YY analysis, I always say that it is like a laser beam. Why it is a laser beam? Because if you take the diameter at the point of emergence of the light, and if you take the same light diameter measurement after 15 feet or so, you will not be able to see much difference in diameter in case of a laser beam. But in case of a torch light, the light will be divergent and the diameter will be increasing to a very great extent. So one may say that while cause and effect diagram or Ishikawa diagram or what we call the fishbone diagram can be compared to a torchlight, but YY analysis is actually like a laser beam. Why? Because when you ask the question why to the effect, we are likely to get one answer. And that is how the YY analysis flows from one effect to the cause, and then again, when we ask the question to the cause, we get another cause, and it goes like that. And it goes for five such series of question and answer. Let's get into the YY analysis through a practical example. As I was discussing in the previous slide about YY analysis being compared to a laser beam and a cause and effect diagram or fishbone diagram being compared to a torchlight. The reason being that in case of YY analysis, when we ask the question to the effect, we are likely to get one answer. And like that, the question and answer continues for roughly five times till we'll get into the final root cause. However, in case of cause and effect diagram, it is not like that. To the effect, if you are asking question, and as we keep on asking question, we keep on getting several answers. And all those several answers could be likely cause or causes. As the number of cause for the effect where it could be many, there fishbone diagram is quite applicable. And to all those group of likely causes, we keep on verifying each of the causes one by one by asking three questions. What are those three questions? Question number one is there a standard operating procedure against the particular cause? Yes or no? Then second, is it adhered or is it followed? And third question is the SOP adequate enough or there is a scope of further elaboration? So depending on these three questions, maybe some of the causes will get eliminated and some of the causes will still remain for further exploration. And that is why cause and effect diagram related solution take a lot of time to practically verify. But in case of YY diagram, it is not like that. The answer could be obtained. In some cases, I have seen in as little time as half an hour. If the right kind of people are chosen practically from the shop floor for such kind of analysis who have adequate process related technical knowledge. This particular example actually was taken from one of my personal experiences in one among the steel mills. And there, the maintenance manager complained that his FD fan reinforcement is needed to be redone because it has developed some kind of cracks. And when I asked him that, has he observed any kind of special observations? So he said that yes, we have been measuring the vibration level, and the vibration level of late has gone very high. And the countermeasure that he takes is cleaning the dust from the FD fan. And he showed me a diagram depicting a particular graph where the vibration has been plotted against the days. And it is seen that, particularly on those days when the cleaning of the dust is done, the vibration level goes down drastically. So there was a very clear relationship between the accumulation of the dust in the FD fan and removal of the dust. So this gives, actually, here you can see the manpower employed and how every uh, every 2 weeks the FD fans were uh, had to be shut down, and the cleaning had to be done. Casual laborers were recruited for that purpose. So company lost the expensive man days as well as the production also. So this problem, of course, was an important problem. And so instead of doing the reinforcement in the foundation, we wanted to just check through the analysis that why this particular problem happens. It appeared to us that the accumulation of the dust may be immediate cause, but we need to go deeper and then understand that why this particular accumulation of the dust happens. So when we asked that question, that why the dust happens, we came to know that the dust is coming through the air, and the air which is actually being forced out through the FD fan is actually coming out of a scrubber, and the scrubber is supposed to be absorbing the dust because water is flowing inside for that purpose. However, the air that is coming out through the scrubber is unable to do that. So when we tried to look into the water flow in the scrubber, we found that water flow has reduced from 40 meter cube per unit time to 24 meter cube per unit time. And again, when you ask the question that how come the water flow came down, then we understood that the conduit is choked because of some precipitation. And what was the precipitation? It happened because of some calcium oxide deposition. And on further inquiry, it was revealed that this called calcium oxide in water was used for increasing the productivity in the plant. So that was a strategic decision, and it seemed that nothing could be done about it. So when we analyzed, we found that instead of really taking care of the cleaning of the fan, it would be a better proposition to do the pipe uh, cleaning once in 3 months, which would be taking hardly 30 minutes every 3 months. So it was much more economic proposal, and the scrubber's basic function was met, and as a result, the FD fan would not face any problem, and therefore the vibration level also we would be able to retain it at a low level. So this is an example, practical example, that through consecutive inquiry and probing from the effect which is seen superficially initially, if we keep digging deeper and deeper, we would be in a position to reach the fundamental cause, root cause, where the action could be taken. And if action cannot be taken uh, at that particular stage, you can go one level up, and you will be able to understand that at which level the action can be taken. And in this case, the choked conduit which is getting choked because of precipitation. If that sedimentation or precipitation can be removed, then the scrubber functions, and therefore the air, the dust from the air can be removed, and therefore the FD fan would not have the deposition, and therefore the vibration level would not go up. So the same thing can be plotted through a YY diagram format. And the only point is that in this analysis format, it is different from other formats. And this particular format has been taken from the JIPM TPM class, the material that was shared. And this format says that you start with the problem statement, and the problem statement in this case is F-defined vibration problem, because that is what actually was observed in the first place, and that led to the subsequent analysis, because it is the problem feeling stage. At what stage the problem can be felt? So for this particular plant, the problem could be felt at the F-defined vibration stage. So the problem started there. And in this kind of YY analysis, what we start where we start is asking a question that was there any action taken to come out with a solution at a for a immediate purpose to stop the problem. Yes, in this case, yes, it was done, and we can call it an intermediate action. May not be a final action, which final action is always the final action which eradicates the problem altogether. It was not eradicating, it was an immediate action taken. So, what was the immediate action or final intermediate action taken by the plant? The answer was cleaning the dust in the fan. And then subsequently, another question is asked after the final action, is it okay? And the answer is yes, it was okay. If we get the answer yes, then we go ahead and keep asking the subsequent question. If this answer is not yes, then we cannot go into the subsequent question answer mode, because it will be futile in that case. Maybe that if it is no, we can go for some other cause and effect uh, kind of tools. Like, for example, it can be done through systematic diagram, or it can be done through cause and effect diagram, or such kind of root cause analysis tools. There are several of them. So, YY analysis requires that this answer be yes. And in this case, because we have got the answer yes, so we can go ahead with the next question. Why did you clean the dust? There was high dust in the air. Why air was dusty? The scrubber did not remove the dust. Why scrubber did not remove the dust? Water flow rate was less. Why water flow rate was less? Because pipe choked due to calcium oxide. Why pipe was choked? Management decided to add calcium oxide to improve the performance. And at this particular point, we actually stop asking any further question, because it is going outside our boundary or scope of the solution. So therefore, we stop here. And the action cannot be taken at this stage, because the system of approving change proposal by all concerned as part of the system would not materialize, because this is quite beneficial for the plant to use calcium oxide for improving the yield. So we came to the action point at this stage, the pipe checking for sedimentation and replacement as part of preventive maintenance if needed. And for scrubber, flow rate reduced, which could not be understood. One solution that came out was that we can connect a water flow meter. And why air was dusty? Dust level in the room was getting more dustier, and so therefore dust level can be measured in number of particles per meter cube. And if the problem of the dust happens, intermediate action that can be taken is the cleaning the dust. Of course, the most economic and beneficial action would be at this stage. And in that case, that earlier subsequent actions could be avoided, except some of those warning level related measures could still be retained, like connection of the flow meter. So this whole thing, this exercise gives us an example of a practical application of YY analysis and how it can really remove a root, identify and remove a root cause permanently. And it is quite a fast method. Only point is that because it is totally technical and it requires the involvement of the concerned maintenance person, production person who have the practical knowledge of the problem. If they sit together, the solution can be arrived at quite fast and it doesn't take so much time like a conventional cause and effect diagram etc takes, where the alternatives generated are too many, and to explore the complete width and length of the problem it takes a lot of time. So we can save all the time and then really come to the directly focus on the solution and then implement it and get rid of that particular problem.